So this is the video demonstration of persistence layer. Here I am explaining the code of persistence layer. First I'll explain map controller.cs file. Starting off we have some necessary using directives reporting essential library like Microsoft.ASP.NET Core.MVC for building web APIs and system for basic types. Here we define our map controller class, which inherits from controller base. Notice the API controller attributes signaling this that this class handles HTTP requests. Our first method is get, triggered by HTTP GET request to retrieve all maps from the data access layer. We return the maps with an HTTP status of 200 OK. Next up we have get square maps, a specialized method that fetches maps where the number of columns equals that number of rows, perfect for square maps. Moving on to the get int id. Wait a minute. Get int id. This method fetches a map by its id responding with the map if found or a 404 not found status if not. In add map new map, we handle HTTP post request to add a new map. We ensure valid input assign creation and modification dates and return the newly created map. Now update map int id map update. Map handles HTTP put requests to update an existing map. We set the modification date and return a 204 no content status upon data upon success. So by continuing, we have delete map. We handle HTTP delete request to remove a map by its ID. If the map doesn't exist, we return a 404 not found status. Now the coordinates. Lastly, the coordinates verifies if given coordinates are within the boundaries of a map within the specified ID, returning a boolean indicating their validity. Now I'll explain the robot command controller.cs file. Uh, in this, we explore a component of a robot controller application, the robot controller API. Now the robot controller API, which handles various robot commands. First off, we import necessary libraries like Microsoft.ASP.NET Core for building web APIs and system for basic types. Here we define a robot controller class, which like before inherits from controller base and handle HTTP request with the API controller attribute. Our first method get retrieve all robot commands from the data access layer and returns them with an HTTP status of 200 OK. Next, get move commands only specialize in fetching only move commands, filtering out other types of commands. Moving on to get robot command by ID. This method fetches a specific robot command by its ID, returning if it is found or a 404 not found status. In add robot command, we handle HTTP post request to add a new robot command. We ensure valid input, prevalent duplicates, and return the newly created command. Now update robot command handle HTTP put request to update an existing command. We check for duplicates, update the modification date, and return a 204 no content. Lastly, the delete command request to remove a command by its ID. If the command doesn't exist, we return a 404 not found status. Now moving on to the persistence, that is map data access file. In this we are into map data access layer for our robot control application. Firstly, we import the necessary NPG library for working with PostgreSQL database and system for basic types. Here we define our map data access class, a static class responsive for CRUD operation on the map table in the database. All get maps method fetches all maps from the map table in the database. We establish a connection, execute the SQL query, and populate a list of map objects with the retrieved data. Next up, update map updates an existing map in the database. We construct an SQL update statement, set our parameters, execute the command, and update the map's information. In insert map, we add a new map to the database. We prepare an SQL insert statement, set parameters with the map's data, execute the command, insert the new map into the database. After that, the delete map removes the map from the database based on its ID. We construct a delete SQL statements and again the same. So for the robot command access.cs, we are again putting the same libraries, that is npgsql, which will work with PostgreSQL. Same for the robot command data access. A static class is responsible for CRUD operation on the robot command table in the database. Our getRobot commands method retrieves all robot commands from the robot command table in the database. We establish a connection and execute the execute. And that I defined in the map data access is all the same for the robot command, same for the delete robot command and insert robot command. Thank you. In this, the map class is a simple representation of a map object in our application. It contains various properties that describe the characteristics of a map. Let's break down each property and understand its role in our map class. First, we have the ID property, which uniquely identifies each map object. Next, we have the column and rows properties, which represent the dimensions of the map. Then we have the name property, which stores the name of the map. The description property is optional and allows for a brief description of the map. Moving on, we have the created data and the modified data properties to store the timestamps indicating when the map was created and the last modified. Now let's take a look at the constructor of the map class. The constructor initializes all the properties of the map object with the provided values, and that's a brief overview of the map class. It provides a blueprint for creating map objects in our application with essential properties such as dimensions, name, and timestamp. I hope you find this explanation. Now moving on to program.cs file. Here we start by creating a builder using the web application create builder method. The builder provides us with a convenient way to configure our application. Next, we add service to the container using the add controllers method. This method registers controller as service in the dependency injection container. After setting up our service, we build the application using the build method. This method finalizes the application configuration and prepare it for execution. Moving on to the configuration, the HTTP request pipeline. We first check if the application is running in the development environment. If it is, we enable the developer execution page using use developer exceptional page. The page provides detailed error information during development to aid in debugging. Next, we enable HTTPS redirection using use HTTPS redirection. This middleware automatically redirects HTTP requests to HTTPS to ensure secure communication. We then enable authorization using use unauthorization. This middleware adds authentication and authorization capabilities to our application. Finally, we map controller to routes using map controllers. This method sets up routing for our API controllers, and that's a wrap. Now we will move on to robotcommand.cs file. I will explain robotcommand.cs file. In the robot command class represent a command that a robot can execute. It contains properties defining the characteristics of a command. Let's break down each property and understand its role in robot command class. First, we have the ID property, which uniquely identifies each command object. Next, we have the name property, which stores the name of the command. The description property is optional and allows for a description of the command. The isMove command property indicates whether the command is related to a movement. Then we have the created data and the modified data properties, which stores the timestamps indicating when the command was created and last modified respectively. Now let's take a look at the constructor of the robot command class. The constructor initializes all the properties of the robot command object with the provide values. And that's a brief overview of the robot command. Now I have explained all the codes. Thank you.
Hello, my name is Rudraksh and this is the demo video of persistence layer. This is the output, and in this we are establishing a connection with the database. Now I am putting the command of running it. It is built and the port number is 5282. I'll copy it in Postman. Five two eight two, and I'll send it. This is all the IDs. Now I'll run the commands. First I'll run the command of getting the ID 3, and then I'll use the move command. After that I'll copy some ID to update it. Now I am making a new ID with the number, I guess 18. We'll remove the ID and all the extra because it get the ID by itself. We'll change the name or description so we can get the new ID. Now we'll post it, and as you can see, before posting it, these are the IDs I have. Last is 17, so we'll get the 18 ID. Now after posting it, now we will check by the get command. That is the 18th ID. Now I'll also run in the database. As you can see here, it get updated. Now I'll update some ID, and that is 18th. We'll change the name to back and send it to check it is updated or not. We'll again get the ID and use. As you can see here, also in database it is changed. I'll run the maps command here. First the coordinate one, it came false because it didn't fall in the coordinate and now as you can see it came true. I'll run the maps command with coordinate id 4. This is my id 4th, and we'll see the table in map. This is the database of maps. Here I am posting a new ID by changing some columns and rows. Here we'll get the new ID. We'll post it, and as you can see, oh, this is a bad request. So it got updated in the database. बंद कर दें. And I copied the 17th ID and changed the columns and rows so we can update it. By put method we can update the IDs. To check it, we will again get it, and as you can see it got updated. We will also see in the database after running it. You can see that name, walk, and column and ID got column and rows got changed. Thank you.